Hi, so in this video, the first video in this series of chemistry tutorial videos, I'm just going to be taking an introductory look at the composition of an atom, as well as isotopes and atomic mass. Okay, so first up, the composition of an atom. Okay, so atoms themselves are made up of three basic particles. They're made up of protons, which are positively charged. They're made up of neutrons, which are neutrally charged, so we'll write that as a 0. And they're made up of electrons, which are negatively charged. Okay. Protons and neutrons are found in the nucleus, okay, whilst electrons are found around the nucleus. Okay, and that's an important point to note. Okay. The composition of a nucleus is defined by two things, okay? So it's defined by its atomic number, which is the number of protons, and it's also defined by its mass number, which is the total number of protons and neutrons added together. Okay, so that's really important. Atomic number, furthermore, also determines the nature of an atom. So the atomic number of an atom, the number of protons that it has, will tell us what kind of atom we have. Okay, so whether we have carbon, nitrogen, hydrogen, or whatever. Okay, so that's really important as well. Okay, so the atomic number really determines what an atom will be. Okay, so I'm just going to quickly run through atomic notation now. Okay, I'm going to use carbon as an example. So whenever we look at an element and we want to do the atomic notation for it, this is how we'd go about doing it. So we put the letter of the symbol of the element there first in the large letter as the base. We then put the atomic mass of the number as a superscript and the atomic mass of the element as a superscript and the atomic number of the element as a subscript. Okay, so we have mass number and we have atomic number. And we have the element of interest here. Okay, another thing to note that a lot of the time you'll see atomic number denoted as Z. Okay, so Z, whenever you see Z, you know that they're going to be talking about atomic number. Okay, so just keep that in mind. Okay, so that's pretty much atomic notation. All right, so the next thing we're just going to be taking a look at is isotopes and atomic mass. Okay, so isotopes are just nuclei with the same atomic number but a different mass number, okay? And this is as a result of a different number of neutrons, okay? So isotopes have the same number of protons but a different number of neutrons, which means that they have the same atomic number but a different mass number. Okay, I'm going to look at a few different types of isotopes of carbon as an example. Okay, so let's have a look at carbon. Okay, so I'm going to look at 4 different isotopes of carbon. So the first isotope is going to be carbon-11. Okay, when we talk about isotopes, we say, for example, the name of the element first, followed by its mass number. So this is carbon-11 because it has a mass number of 11. Okay, carbon-11 is actually artificially produced. Okay, and this is because it's naturally very unstable. Okay, so we can never find it naturally occurring. It's always going to be artificially produced. The second type of isotope of carbon we look at is carbon-12. Okay, this is actually very stable, and so it's naturally occurring. Okay, we actually find it naturally occurring, and it's found in fact we can say 98.9% of naturally occurring carbon is found as carbon-12. Okay, so a really large percentage of natural carbon is found as carbon-12. Okay, the third type of carbon isotope we're going to look at is carbon-13. Okay, this is fairly stable. Okay, and it is found naturally occurring. Okay, and it actually makes up 1.1% of naturally occurring carbon. Okay, so as we can see, carbon-12 and carbon-13 make up all of naturally occurring carbon. Okay, the last type of isotope we're going to look at is carbon-14. Okay, and this is also very unstable, as is carbon-11, and so is only found artificially produced. Okay, so those are 4 different isotopes of carbon, and as we can see, they all have the same atomic number, but they have different mass numbers. With this carbon, we can say having a neutron number of 5, okay, because it has a mass number of 11. 6 neutrons here, 7 and 8 neutrons here. Okay, so as we can see, each of these differs in the number of neutrons that it has. Okay, so the last thing I'm just going to look at with you guys is how to determine the atomic mass number of a particular element. Okay, and we do that by averaging the atomic masses and the abundance of each of naturally occurring isotopes. Okay, so in the case of carbon, okay, let's use carbon as an example. In the case of carbon, this is going to be, as we saw, carbon-12 and carbon-13. Okay, as these are the only two forms of naturally occurring carbon. Okay, so the way that we'd work this out is we'd multiply the mass number by its abundance. Okay, so we know that this occurs in 98.9% of carbon is found in carbon-12, so we can say 0.989. Okay, and then we add this to the abundance of the other isotopes. Okay, so for carbon-13, it's found as in 1.1% of naturally occurring carbon, so this is 0.0011. Okay, we would add this together in order to get our atomic mass, and when we calculate with this, we find that it's equal to 12.01. Okay, and you can find that on your periodic tables, okay, where we look and we see that the mass number of carbon is actually equal to 12.01. Okay, so you may be asked in exams to sometimes calculate the mass number of particular elements given the abundance of certain types of isotopes, and this is how we go about doing it. So you multiply the mass by the abundance, add them all together, and you'd find the overall mass number. Okay? Alright, so that brings us to the end of this video. Thank you.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.